Antiderivatives Part 1. A function, big F, is an antiderivative of little f on an interval provided the derivative of big F is equal to little f. Let's do an example. An antiderivative of x squared is 1/3 x to the third power. Check that the derivative of big F is equal to little f, which is x squared. Well, the derivative of big F is the derivative of 1/3 x to the third, which, once you take the derivative and simplify, is x squared. Now, even though an antiderivative of x squared is 1/3 x to the third, it's not the only antiderivative, and I have two other examples here. And in all cases, you need to check that the derivative of big F is equal to x squared, your original function. So one antiderivative of x squared is 1/3 x to the third plus 8/3. But you can see that there are a lot more. And also you can see that all antiderivatives of x squared are of the form 1/3 x to the 3 plus c, where c is an arbitrary constant. So when you look for an antiderivative, you're actually looking for what we call a family of antiderivatives. Let big F be any antiderivative of little f, then all the antiderivatives of little f have the form big F plus c, where c is an arbitrary constant. So you get a whole family of antiderivatives that only differ by a constant. Let's do an example. Now, with antiderivatives, you have to think backwards. We want to find all antiderivatives of cosine x. Who has a derivative of cosine x? Well, by now you probably know that sine x has a derivative of cosine x. And so all antiderivatives will be of the form sine x plus a constant. And as always, the way you check your work is take the derivative and see if you get back what you started with. Now I'm going to introduce some new notation. If you say this expression, you are saying the antiderivative of little f is big F plus c. And big F plus c is actually a family of antiderivatives. The expression on the left is called an indefinite integral. The function f of x is called the integrand. The dx tells you that the variable of integration is x. It says you are going to integrate with respect to x. You might have heard me say when we take derivatives, we're taking the derivative with respect to x. So when you do an antiderivative, same thing. You have to know with respect to what variable. The thing on the right-hand side is called your antiderivative, or your family of antiderivatives. And then it must be true for this equation to be true. It must be that the derivative of big F is equal to little f. Now, your first rule of antiderivatives is the antiderivative of x to the p is equal to x to the p plus 1 over p plus 1. Now, you can see that this rule doesn't work if p is equal to -1. You would end up with p plus 1 being 0 in the denominator. So it doesn't hold for p equaling -1, but it holds for every other value of p. Let's do an example. What's the antiderivative of x to the 7? Well, it's x to the 8 over 8. Check that the derivative of x to the 8 over 8, the derivative of that should be x to the 7. And in fact, it is. For this antiderivative, in order to use the power rule, you need to rewrite the integral. So instead of 1 over x to the 3, I write it as x to the negative 3. Now you use the power rule. Now the power rule tells you to add 1 to the exponent and then divide by that new exponent. Then you just have to clean it up, and you can find the antiderivative of 1 over x to the 3 is equal to negative 1 over 2x squared plus a constant. If it's written in radical notation, you're going to have to rewrite the integral in order to use the power rule. And so the fifth root of x is equal to x to the 1/5 power. And then I go ahead and use the power rule. And then I simplify. And so the antiderivative of the fifth root of x is equal to 5/6 of the fifth root of x to the 6th plus an arbitrary constant. Now, here we just have the antiderivative of, well, of what? Well, of 1. The antiderivative of 1, and then all you have to remember if you're going to use the power rule, is that 1 is equal to x to the 0. So I get x to the 1 over 1 when I do the antiderivative, and that's just equal to x. But you kind of already knew that, didn't you? The derivative of x plus c is equal to 1. And so the antiderivative of 1 dx is equal to x plus c. Now if you had a 5 there, then the antiderivative would be 5x plus c. And again, just check. What's the derivative of 5x plus c? It's equal to 5. So it works out great. That's the end of part 1. I'll see you in a bit when we get to part 2. Take care and have a great day.